Section 4, I want to give you some ideas about graphing polynomials. We'll generally use our calculator for this, but certain things you need to be able to recognize and not rely on the calculator for. Here we're talking about the word degree, the one in red at the top. So when we say we have a polynomial, the term degree refers to the exponent that is the largest in the entire polynomial. So in the first polynomial, the x to the third tells us this is a third degree polynomial. The second one is also a third degree polynomial. The next one is a fourth degree polynomial. The next one's a fourth degree polynomial. The next one's a second. Next one's a 5. These are kind of obvious. Just look for the highest exponent. The last one is not so obvious. If this were multiplied out, x times x times x would be x to the third. So this is actually a third degree polynomial. Now, graphs of polynomials are always nice and smooth, and the term continuous means there's no breaks in it, like asymptotes or holes in the graph. You'll see some of that in the future. However, let me show you some observations that we need to have in mind. When we talk about the degree of the polynomial, the significance of those numbers is we can get a good idea of what the graph looks like from that. All polynomials that are odd degree, that means exponents of 3s and 5s and 7s and things like that, I don't think ours will ever be beyond 7, have a graph where on the left it goes down and on the right it goes up. Now I haven't put anything in between. These two lines would be connected, and so all this is telling us is what the graph looks like on the right and on the left. And if the coefficient in front of the x to the third, fifth, or seventh term is negative, the graph will be going up on the left and down on the right. The way I usually find it easy to remember this is the odd degrees, the word odd starts with the letter O, have lines going in opposite directions, one up and one down. O odd, O opposite. Even degree polynomials, things like x squared, x4, x6, are kind of easy to remember because we've been studying x squareds or quadratics, and we know that a normal x squared graph is going to be going up on the left and up on the right. Well, if the number on the front is negative, it's going to be going down on both sides. Well, this is the same thing that happens if the degree is a 4 or a 6 or an 8. Any even degree is going to look like the x squareds that we're familiar with, up on both sides or down on both sides, depending on if it's positive or negative. This page is available as a handout in the MyTC if you want to print it out. So let's see. Here is a third degree polynomial like we will be working with in this chapter, and we need a graph of it. If I take out my calculator and type this out beside my y equals and push the graph button or zoom 6, this is what I see on a standard graphing window. Is this a plausible graph for that polynomial? If this is a third degree polynomial with a negative on the front, it's supposed to be going up on the left and down on the right. Well, this one is indeed going up on the left and down on the right, and there's a continuous curve in between. So I'm confident that this is the correct graph for that polynomial. There's nothing to be done. Everything's okay. This polynomial, when I type it into my calculator and see this graph, I recognize a little discrepancy. Third degree polynomials that have positive coefficients are supposed to be going up on the right and down on the left. This one is indeed going down on the left, but you don't see a line on the right that's going up. Now that tells me something about my settings on my calculator. Here's the standard settings, negative 10, 10, negative 10, 10. I need a larger value for x. Now that's the x max setting. So if I just change my X max setting to 15, you see that I get the other portion of the graph that was missing, the one that's going up on the right. And I need to understand that the two lines should be connected. There should be a continuous curve from this line to this line. And so that also tells me I need to change a setting on my window. That Y min needs to be much smaller than negative 10. Now again, you can experiment with this until you get a good number. And you can see the numbers that I've used over here in my window settings. And we have a good graph for that polynomial. Let's try that with the fourth degree. Just like with the previous one, if you type this into your calculator and push the graph button on a standard window like Zoom 6, you see this graph. Is it plausible? Well, yes. A fourth degree goes up on both sides. This is going up on both sides, and it's connected in the middle. That is the graph. Nothing to be done. If you type this one on your calculator, you can pause the video if you want to go type it, because that's a lot of typing with those fractions, and push the graph button, you see this. Does that look plausible? Well, if it's a fourth degree polynomial, positive number on the front, it's supposed to be going up on both sides. What I see on this one is there is indeed a line going up on the right, but not on the left. So where do we need to adjust the window on this one? Farther left. So we need to change the X min setting. Again, I've just chosen negative 15. You can experiment with this and get the good number for X min. Once you see the other line that you're supposed to have, you can worry about joining the two lines. And again, with this one, it means adjusting the Y min until you get a continuous line.